A student want to use two PN junctions diodes to convert alternating current into direct current. Draw the labeled circuit diagram she would use to explain how it works. Okay. First of all, we need to know here which is the device used to convert AC signal into a DC signal. The device is a rectifier. A rectifier is the device which is used to convert the AC signal to DC signal. And a student want to use two PN junctions. Okay, let me draw the diagram of the two PN junctions with the two primary coils. I will take the first, this is the first primary coil. This is the first primary coil. And I will take, this is the second primary coil. Secondary coil. So for this one, I am going to connect with junctions, PN junctions, two PN junctions with the inlet. So this is, I will connect to two PN junctions. The first one, and the second one is from here. And these two will be connected to a transformer to a load resistance. Here, load resistance, that is, and it is connected from here to a load resistance, that is RL here. Okay. I just give the names here: A, B, C, D. AB is the primary coil and CD is the secondary coil. Okay. Now, if this is the PN junction of the first one and this is the second PN junction. If one PN junction is there, that indicates the half wave. If two PN junctions are there, that indicates the full wave. Since we are going to take here two PN junction, it is a full wave. What is the full wave here? Full wave is it will fully convert the AC signal to a DC signal. That means, for example, if I take one PN junction, that means it will, the waves are like a positive and the negative waves are there. Positive and the negative waves are here. This is the positive wave and this is the negative. This is the positive and this is the negative and this is the positive. Okay. And this will convert it into a full, all the full positive and the negative it is converted into the output will be the full load. That is, it will be connected. The resultant output will be like this. That means first one is the positive and the second one is negative. So in this way it will be converted. This is in case of the two PN junctions wave. Okay, here I will attach one. For example, if I am going to send the signals through the primary coil like this, if I send a signal through the primary coil like this, then it's a positive and negative and the positive and the negative. Concentrating on here for the first one, that is a positive wave signal. Then due to the mutual induction, the P is equal to here the P is equal to the positive and N is equal to the negative. Okay. In the reverse order, if this is in the forward direction, this is in the forward, then here R0 is equal to the 0. And in the reverse order, P is the negative and N is the positive. This is in case of the reverse. In the reverse, this is the case. Okay, and here the RD is equal to 0. The output will become 0 here. Okay, this is the forward case and this is the reverse case. And the second part of the question, give the truth table and a circuit symbol for NAND gate. Okay, here for the NOT gate and the AND gate together we form a NAND gate. NOT gate will use the result like, for example, X and Y is the X is the input and Y is the output. If X means the input is a 0 and the Y output is 1. And if it give input is 1 and the output is 0. And in AND case, here the resultant is if 0 and 1, 1 and 0, 0 and 0, 1 and 1. If 0 and 1, the output is 0. If 1 and 0, the output is 0. 0 and 0, the output is 0. 1 and 1, then only the output is 1. The combination of these two, that is the NAND gate, so we'll get the resultant is, input is first one is X, Y. First here it is 0, 0, 0, 1, 1, 0, 1, 1. If NAND gate, if I am going to apply here, then 0, 0 is equal to, that means 0, and 0, 1 is equal to 0, 1, 0 is equal to 0, 1, 1 is equal to 1. Then the resultant output Z is equal to, that is 0. If it is a 0, if it is 0 in the NOT gate, the output is 1. If it is 0, it is 1. And if its output is 1, if it is 1, then it is equal to 0. This is the truth table for NAND gate.